And now let's rock out. What we're going to be doing is, this is a follow-up to the last class that was just like there's a stone in your hand and I'm going to draw the stone. I'm going to show you a few more little details on drawing the stone that's in your hand, and then we're going to draw not the rock, but geology. We're going to think about how do you draw sort of the bones of the earth. And that is where we get into geeking out on geology, and it's really, really, really fun. I think that when I first learned, as far as, it was kind of looking at geology as a thing, I saw this book of like how to identify rocks. And I thought it was all about like picking up a rock and saying, this rock is this, and this rock is this, and this rock is this, and this rock is this. And that was kind of neat to have names for things. But what I didn't really get, and once I saw that, like, oh no, this is actually what geologists are all about, is identifying the rock is a tool to reading a story. And that story is embedded in the land. And it's this story of the history and the processes behind how all these rocks came to be there. And so being able to say, pick up a rock and go like, yes, this is chert, right, is one thing. Then being able to look at the landscape and see like, okay, that layer there, that's where the bedded chert is, and it's hard, so therefore that made that hill over there, and that valley there is because of the earthquake fault that runs between them. And then also trying to kind of analyze these rocks and kind of get into the story, like how did these things develop? So how did these rock formations come to be, and using inference to figure that out. And then also looking at those rock structures themselves and seeing how they then influence the landscape that we see around them. And that just gets really, 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 really fun. And so we're going to kind of dabble into all of these areas today. I'm going to start with just a few more details on drawing rocks. And then we are going to get into some sort of geology visualization things that I think you're going to find are interesting and useful for your nature journaling. I'm also going to be showing you a few examples from my nature journals of where I've played with some rocks. Let's jump over to the document camera. All right. And we are going to focus. There we go. We're good. So you have a rock that you are looking at, and again, last time we explored ways of drawing the textures in rocks and things. The maybe starting with sort of the outline of something, and then looking at what are the any sort of cracks or other structures in it. Is it made out of are there little kind of grains of things, how big those were. We also looked at how putting a little bit of shadow and shading on these things does a lot to really define their shape. Once I put kind of a clear shadow here and on this side, we kind of get the idea that, oh, this is a little part that sticks up. And then there's an angle here. So this part is in light, and then we go around that angle. So you can sort of start to, the shadows really do a lot to kind of define the form of the rock. But because we were, there were not enough minutes in an hour, there's a number of things that I wanted to point out that are also really useful to include and to think about as we are studying these things. And so I want to kind of geek out on that just a little bit more with you now. So one thing I want to think about is the composition of this rock. So if it's sort of all sort of one kind of unified sort of crystalline structure, is it something that's made out of tiny little grains? It's very useful to get out a little magnifying glass and take a close look at what the rock is made out of. And so one way to do that is to draw the rock, and then you can draw either a little circle kind of tucked up behind it, or another fun way to do this is to draw a circle on the rock itself and then have that go out. And I'm going to lightly block in a circle here, and then that's going to help me trace a more roundish circle here. And so when you see that shape, it becomes really clear that this is a detail of this area here. So that's a useful little kind of visual tool. I'm now going to kind of zoom in on this area, and I'm going to do an enlargement of what I see here. If the rock is a sedimentary rock, one made out of little grains of sand, I want to first pay attention to the shape of those little grains. You'll find in some sandstones that the grains are sort of smooth, little kind of rounded grains. And on others, they are angular bits. And so the nature of the shape of those is one clue that geologists use to analyze our rocks. Another thing I want to look at is this is an interesting idea, the idea of how well sorted the grains are. How well sorted the grains are. So if people are wondering what pencil I'm using, this is a general's layout, extra black. So by sorted, I mean, are all the grains roughly the same size? Or, excuse me, or is it a hodgepodge of big grains and little grains? Right? So if it's this sort of even matrix of grains in there, right, then I'm just going to draw those in. And what I do is I first sort of draw the ones that are on the surface that is closest to you, and then you just start drawing in other ones behind them, like that. So you start with the ones that are in front, and then eventually you're going to be overlapping things, and then you get depth in your drawing, because some are in front, some are in back. If it is an uneven matrix, though, if the sorting is different, like there may be particles of different sizes in here. So I'm interested in how well sorted it is and the shapes of those. And then I can fill in some of those spaces around them. And it's good on something like this to both show and tell. Show and tell. So I draw my little picture of it, and then I can write next to it sort of rounded grains. Unsorted. And that gives people this little zoom in to what is here. If you know another thing that you can do here is that you can also you can look at the general size of these grains. A lot of the the classification of sandstones is done by the size of the grains. So if it is little particles of sand, like you're used to seeing on the beach, then it's a sandstone. If you took those sand grains and you then pulverized them, started to smash them down, you get little particles that were much smaller than you typically see in sort of, your sand grains on the beach. And this might be a siltstone. Those pulverized even more make a clay. And so the size of these grains also is important to you. So if you can, roll the grains around on your fingers, right? And you kind of like, oh, look, I've got these grains. You've got a sandstone. If, as you do that, you can't really feel the individual grains, but you can feel the grittiness of it, you've got silt. And if you get that powder in there and it just feels smooth to you when you're doing this with your fingers on it, then you've got clay. So you want to think of also what is it made out of? The same is true for rocks, that if we took this rock and then we melted it and let it recrystallize, as a rock cools, crystals start to form inside that cooling space. If it cools very slowly, you get big crystals. If it cools really fast, you get no crystals. If it cools medium slow, then you get small crystals formed in it. So I can also look at other rocks and sort of, let's say we had, I don't know, I'm going to kind of draw that kind of a more kind of angular edge here. And this is going to be sort of a little chunk of granite here. And the granite, as the rock cools, the crystals inside it will start to form on each other, and then those will merge into each other. So it ends up being this sort of interlocking mass of these different minerals of different colors, of different transparencies, and that is really it's fun to explore. We in the previous class we looked at that technique of using the sponge to kind of get a really neat, fast kind of granite texture. You kind of blotch that on there, and it's really easy for somebody to take it for granite. But we can do the same thing with this. And I'm going to pull that out. And you want to get your little hand lens out if you're looking at a chunk of granite. You want to look at the shape and the size of all of those little crystals that are going on in there. So there might be, there will be some dark ones. And what is their shape, right? Is there a shape to those? There's going to be here are, so in this I'm kind of showing that I have at least sort of 3 types of minerals in here. One I'm sort of showing with these sorts of marks, one I'm showing with these marks, and the others are these ones here. So I'm looking at these and thinking to myself, all right, I've got these sort of slightly pinkish. I've got these black ones. And I've got these white ones. So you're thinking about what is the composition of this rock. If you're looking at a rock in this way, in this sort of zoomed in way, um, then you're really starting to look at this rock like a geologist. And I want to show you these kind of interesting diagrams that geologists use sometimes when they're trying to identify what type of rock something is. And what they will first do is they will identify exactly which minerals they're looking at. Each one of these different little guys in here, these are different minerals, right? So they'll identify those. And then depending on the proportions of those, they're going to figure out what type of rock it is. But if, let's say, you're not good at looking at a mineral and saying, oh, I know what kind of mineral this is, you can actually still do a ton of really fun stuff just looking at this. Let me first, I'm going to show you how their little diagrams look. So I've got my little geology book here, and I had Post-its in here earlier, kind of took them out because I didn't think I was going to be doing this, but then I went on this tangent, and I'm really excited about doing it now. Let's see if I can get back to those diagrams in a moment. Maybe it's more towards the front. Yes, there we go. Right. So actually, this one here, this little triangular diagram, I'm going to zoom down on this. And at first, you're going to look at this like, okay, this I want to learn some tricks for drawing rocks, but this is actually this is a really cool way of setting up a diagram. And you're going to see in a moment that there's something in your journal that you can do that's very kind of similar along these along this line here. So let's say you are looking at a.
Could you maybe get a little bit closer? We're having trouble reading. Also, there's a question. Which book is this?
Oh, this is the lovely Geology in the Field by Robert R. Compton.
Excellent. Thank you.
So it's kind of a how-to-do manual for the geologist who has, dirty knees and is kind of grubbing around in the field and is, picking up things and figuring stuff out. All right, so but let's look at this. So at first, when I first saw these, I thought like, oh, okay, this isn't very helpful to me. And then I realized like, oh my gosh, I see what you're doing. This is brilliant, right? And then we're going to look at how I can kind of play with this idea in my journal. We've all seen a graph like this, right? We've all seen a graph here where you've got something here and something here. And so let's say you had, I'm going to put on this axis the percent that is clay, right? And on this axis, I'm going to have percent that is sand, right? So if I'm looking at a rock, I could plot it on here and say that this rock is, let's say if it's 50-50, it is going to be, it's going to be a little spot in there. If it is actually mostly sand, right, then it's going to be a little dot up in here. Right. So does that make sense? So we've got two axes here, and all right. So now we come back to this. Look at what's going on here. So this is a little draw. So for naming a sedimentary rock here, 3 corners, and at one corner is sand, one corner is gravel, one corner is silt and clay. So let's say that this rock was completely 100% sand, right? Then on this axis here between, say, sand and clay, you'd be right down here. And between sand and gravel, you'd be right here. If something was completely 100% clay, it would be here. But let's say that something is what did we do here? This was mostly sandstone, right? So mostly sand. So let's say it is 80% sandstone, and there's no gravel pieces mixed into it. So what they would do is you'd imagine this along this axis here. You would put your dot somewhere in here, and you are now, you're right there. Now, what's cool about this though is it allows me to, in a graph, actually look at 3 factors all at the same time. So the way that this works is that you would say, let's just look at sand and clay. Between those two, what proportion of it is sand, what proportion of it is clay? Let's say there's a few little gravel chunks that are mixed into it. But of the sand clay part, just ignoring the gravel, let's say it is 20% sand, and so it's closer to the sand and there's less silt and clay. What you would then do is imagine a line that goes between here and this other point. And what I'm going to now do is I am going to say, all right, between sand and say sand and gravel, how much of it is sand and how much of it is gravel? And then you would say like, well, there's not very much gravel, so it's mostly in here, but maybe here. What you then do is you put another little point in here, and I'm going to draw a line to that corner. Where those two intersect actually gives you a point on this graph right in here. And you'd say, all right, this is a sandy conglomerate. And so what there are then is this allows you, if you put at 3 corners, 3 different variables, let's pop up here just slightly. There we go. 3 corners, 3 different variables. I know. Let's say you don't know how to identify feldspar from quartz. Don't worry about that right now. Let's just say that we've got these 3. There's 3 different minerals. What if for this rock, let's say you've got your pinkish one, you have your black one, and your white one. You could make yourself a little triangle like this. And at this corner here, we're going to put the pinkish one. And at this corner here, we're going to put the blackish one. And at this corner here, we're going to put the white one. So let's just think about this as a visualization tool. Maybe you want to use it here in geology land, but this also could be applied for thinking about all sorts of other different sorts of things. Anytime you want to make a 3-dimensional graph. Let's just look at how much of this, let's say there's the amount of white in here. So that's white, that's white. These ones are all gray. So I'm now looking at the amount of white, and then this is white down here. Is there more white or black? And I go like, well, there's more black. I mean, sorry, more white. So was a little bit more white. How much more white? Maybe roughly in here. Okay, so then I draw a line between that and the other corner. Now I can pick 2 other things. Let's compare, say, the black with the pink. Right, so there's a little bit of black, and then the pink is in here, so there's a lot more of that pink. So we're closer to there, and that's gonna maybe put myself roughly in there. And where those 2 lines intersect is a point in this hypervolume, this 3-dimensional space that we've created here, that shows the relationships of the proportions of each type of these minerals. Now, what in a geology book, what they would then do is they would give you a little diagram and it says that if this is is feldspar, this is mica, and this is quartz. You know, they will give you names for what type of um, of rock that is. We don't have to worry about that. We've actually you've recorded the data there. So without even knowing which minerals you're looking at, you have now made a little diagram of the proportions of these three things. And that's really, really cool. That's really, really useful. So this little three-dimensional triangle graph is something that you can, as a way of quantifying things, kind of, it takes geeking out to a whole new level, right? Of now, let's, like a geologist, you're finding yourself looking at the proportions of these things in that little space. So that's just a little bit more on the rocks. But let's now think of rock units themselves and the landscapes that they form. I'm going to pop up here. I am going to zoom out. So rocks form underground, connected to all sorts of other things. And what geologists look for, what geologists are really excited about finding, is rocks that are in place. So you know, you're exploring around, and all right. So here are some rocks in place. So I'm looking out here and I'm seeing these rocks that are coming out in these flat layers. Each one of these layers is a different type of a rock formation. And, right? And so what's the type of rock that is happening here, making this steep cliff, is different than this little bit in here. And if you see these kind of layers, these are a place where these layers are kind of laid down flat, and the ground has been eroded around them, and we're now seeing these layers made visible. You can go up to each one of these and draw one of the rocks that's from here, one of the rocks that's from here, one of the rocks that's from here. You can also then make a diagram of this whole feature. One way of doing that is I can just make a landscape drawing like I've got right here. But let's take this a little bit further and sort of just geek out on some visualizations here. One second. So I've got this rock formation. There's a steep cliff. It slopes out, then down, down, and then there's this part here, and that is on the ground here. There is kind of a rough, broken part on the top here. But here instead, oops, I'm totally off the screen. Sorry about that. So first, people are wondering about the third dimension on that little triangular graph. So if this one here, if I did this one relatively accurately and this one here relatively accurately, this one here will automatically also fall into place. So it would be, they would all kind of cross through that same point, the proportions of those. So if I looked at, say, you know, the amount of white to pink, it would be mostly pink, a little bit of white, not quite as severe as the black, and then I'm kind of pulling through there. And that gives me kind of a region in this where those overlap. So now back to this guy. I can draw the image that I see in the landscape. I can also make a diagram of it. And really what I'm looking at here is there is one layer here, there's another layer here, right? There's another layer here. There is another layer here. And these are all just layers of rocks built up like a layer cake. So I can make a side view diagram just like this. And that conveys a lot of information about what I'm seeing. And then I can go up to this, I can collect a sample from here, I can collect a sample from here, I can get some details about these different sorts of things. When you see this sort of a thing going on, there's, with these sort of slopes and cliffs, it's interesting, where you see the cliffs, these are often rocks that are harder and more resistant to erosion than these slopes here. And so what I can do is, what people will do is they'll then take something like this, and we're going to transfer this, how it looks out on the landscape, into another little diagram. And so here, I am going to make, there's a layer on top. And you can, and that layer, I want to try to figure out, is it more erodible or less erodible than this straight one down below it? Maybe it's about the same. And there's a thicker unit below that. So I can measure how thick this is, how many meters thick this zone is, how many meters thick this zone is. I can describe them with their color and texture, or fossils that I find in them, right? Let's say I find fossils in this one here, and then blow those up and sort of show, what those fossils look like. Now this layer here, this sort of outslope, this material is a softer material. And so it's not as cliff forming. The really hard ones make good cliffs. If this, imagine that imagine you've got a cliff. If it's made out of really, and here you are standing looking up at the cliff. If this cliff is made out of really hard material, it stays vertical, right? There's a big cliff here, you can climb up it. But if this material is soft, it will quickly kind of erode to a slope. So what I can do is, what geologists will do is, on these little diagrams, there's now kind of a thicker unit below it, but they're going to show the hardness of the layer by how far it sticks out. So there's then a layer that is about a little bit thicker. There you go. This one I'm going to draw kind of sunken in a little bit, because I'm showing that it is more easily eroded. Now here, when we look at the landscape, this is sticking out. The reason it's sticking out is because it's eroding down like that. But you imagine sort of trying to wear down all these surfaces. This one here is more erodible, so it's at more of a slope here. And then we get to another cliff forming one. And then there is a really strong cliff forming unit that is down below that one. So geologists will make this little column, unless for some sort of in rare circumstances, kind of chunks of ground get flipped over on themselves, very rare. Generally, what you're going to find is younger rocks up here, and as you go further down, you're getting increasingly older fossils, older and older and older rocks. And so you can make yourself what's called a stratigraphic column in an area where you can write out your descriptions of those different types of rocks, put in their color, all right? And that's a really fun way of exploring an area. Another thing that I can do, so here's my stratigraphic column, but I can also have fun with something like this sort of side view. I can take this and turn it into a block diagram. I'm going to take this edge, pull it down. I'm going to draw lines at an angle up here. Here is the upper edge of this cliff. Here's this top surface. And if these layers are flat, as I'm seeing out here in this desert, I'm going to just put these ones up at an angle. Doing this helps me visualize these landforms as being things that kind of cut into the hill, that break into the hill. And just to compare that with when you're looking at this, you're just you're seeing the landform, right? Here is getting yourself to really kind of envision these as these chunks of these sections of rock, three-dimensionally into the mountain. If I want to, you can add, sometimes these rocks units, they'll have different colors to them. But here, again, you're just trying to get yourself to visualize what is happening in this three-dimensional space. Let me pull up some nature journal pages that have some examples of sort of geologic stuff happening on them. So this one is, we're going to start off with something that is kind of closer to a sort of a landscape sketch. But what I'm doing here is it's by turning it into a labeled sketch where you've got these sort of names of these different canyons, where the glaciers are, and what these sort of major features are. I'm starting to kind of transfer over to just sort of, here's a picture of this landscape. So I want to start to understand what is happening there a little bit more. So just starting to kind of to sneak over from the direction of looking at sort of the landscape for its own sake to now starting to want to kind of to understand that landscape more. But here, not even yet going deep into the mountain. Let's take a look at a different set of explorations. Here, what I've got is there's a little canyon, and there's a series of rocks that are sticking out along the side of this. And what I'm doing here is I am making my guess about what is making this little ridge of rocks kind of exposed here. And so here's a little kind of just cross-section diagram of it. I think that I get up here and I see these rocks, and I see that a lot of them, there are these planes on them that seem to be kind of pointing down into the ridge here. And so my guess was that there was a layer of these rocks that is then partially exposed in this erosional feature here. And so the stuff here at the surface, that's what I observe. Then adding this in is my guess, my explanation of what could be going on underneath the ground there. And do I know? No, I don't. But this is kind of, it's fun to sort of speculate and wonder. Here's one other thing that's kind of fun to do. If you look over here, I put in a little fossil down there. Maybe some Australopithecine, I don't know who this is going to be, but somebody's little bones are down there. Let me take a look at a few other things from, oops. All right, so this is, I'm exploring up in the Sierra in a valley, and I come to a place where a tree has fallen over, and it's revealed the layers of the soil, much as you'd see layers of rocks. I'm seeing layers of soil here. And here is a little vertical column of what that soil is doing. And so there's this white layer down below. Then there's a thin topsoil here. I've got scale over here. This is 10 centimeters. So you can see how kind of this, I could have done this just as a column like that, as a vertical column. But I think it's a lot more fun just to turn it into a little three-dimensional thing like this. And I sometimes like to draw little pieces of it falling off and kind of accumulating in piles on the side. Here's another example of geological thinking. Now we're getting much more kind of close to this sort of what we're, what geologists are up to. I find a place where there are some kind of cleanly exposed rocks in place. This is actually along a beach where there was this section of rock that came out like this, making a little wall and extending out into the water. So I was able to walk up to these and draw the layers that I saw. And so here is on this map, if you draw a line, so if I draw a line between A and A prime here, that's this cross section right here. Here's me for scale. And B prime here, that is cutting across here. So you can see these sort of same layers of rock, where you get this sort of this mudstone gray layer, this area with the fossil clams in it, and I can also sort of follow the angles of these ground until I kind of lose them in the sort of down further. I don't know exactly what direction they're going, probably continuing in the same direction, but I don't have evidence for that. So where I can't see, I don't draw. Here's an enlargement, or actually life size, of where all the fossil clams are. So using overhead maps, using block diagrams, using cross sections, these are great ways of describing the geology around you. I'm going to show you one other visualization of these sort of things, just to kind of get you starting to think about the sorts of things that you can start to play with and do the more you get into geology in your journal. And that is this really colorful and weird page right here on Pi Day. So it was Pi Day. And 2015. And what this is a diagram of a small limestone cavern. Right? It was a sort of undeveloped limestone cavern. And I just wanted to sort of show you how kind of a system that I came up with for describing this that was really fun to do. There are two views that I'm showing here. This right here is a top view of the cavern. This, starting up here and coming down like this, overlapping here, this is a side view of the cavern. So if you walk into the cave mouth here you are walking into the cave mouth, little drawing of you for scale, right? You can go up into this big room up here. Right? So here's that in the side view. But here in the top view, you see that actually you're coming in and you'd be going into a little room that is further back there. And on your right-hand wall over here is an entrance, a lower duck down entrance to another cavern system. So what I did is I switched colors. So this area here in this view is in front of this. And if they were all done with the same color, that would get really confusing. So just ignore the red now and ignore the blue and look only at the orange. You're coming down into space cavern A here. So here's cavern A, that's here. And it then comes down fairly steeply into cavern B here. Here's cavern B. And cavern B has several other crawl spaces that come off of it, which you see kind of coming down here. So that's all kind of coming down here and going down into cavern B and into these lower crawl spaces. But also in cavern A, there's another door. right? That's here. Now we're going to jump over to the red. And if you go through this one, you can walk this direction until you get to a hole, right? You walk this direction until you get to the hole. And I got a rope and climbed down this and came into another lower chamber down here that had water in the bottom of it. And so here's me sketching beside that pool, right? And the way I'm drawing that in here is here's this coming down to where this is. So here's this part is coming down here to where the hole is, big drop. And then this dashed line around here is the shape of this other chamber down below it. So this is a side view with 3 colors matching up with this top view with 3 colors. And what it allowed me to do was to just geek out on this very sort of strange 3-dimensional system. Playing with geology gets you often thinking about all sorts of angles and the dimensions of things. It's really, really fun. Last little kind of fun thing about this is that this was done at midnight. But when you're in a cave, it's pitch black anyway. So it didn't matter what time of day that I went in. But I went into this cave at midnight and then mapped this whole business out. And that was just a ton of fun. You because there's no light that penetrates past essentially this spot here. It might have, if I had done this during the middle of the day, it would have looked just the same to me as I went down there. But this is just sort of one other thought of ways of visualizing things. So we've got, we have details that we can put in on a rock of the grains, the shape of the grains, the crystals, the shapes of the crystals, the colors of those. We have this sort of new idea of this triangle graph and plotting things. You can make for each type of rock that you find, if there are 3 different variables that sort of that make it up, you can use these sorts of graphs to describe that. We also looked at making a block diagram to help you think about and understand the structure of whatever phenomenon you're looking at, and how that kind of gets you, so you're not doing a kind of landscape painting, but trying to understand what is that underlying structure that landform is built off of, and then how to convert that into a stratigraphic column where you're giving an indication of the relative erodibilities of these different things, adding those in combination of drawings, descriptions, whether you're finding fossils in there, you're looking at the grains in these, comparing the grain sizes in these. Also, one thing I didn't mention before, sometimes there's a change in one unit. It might be coarse grains at the bottom and fine grains towards the top. If so, you'd want to add little written notes in there about that and describing what you're seeing. These are all tools in our nature journaling toolkit that allow us to play with geology in a different way. So if you are, especially in an area where the bones of the earth are exposed, right, where you've got rock formations that are sticking up, let's see if we can start to think 3-dimensionally, think visually, document it, describe, record that in our own nature journals, and we'll see what we see. I hope this gives you some strategies to start to play with geology in your own nature journal, and have some fun with this. You don't need to know the names of all the rocks to really be able to look at them in a very nuanced and sophisticated way. And so on one hand, you have just picking up a stone and describing that stone. The other is that when we start to find these rocks in place, how can we draw and describe those features that make up the landforms all around us? Thank you for being here, everybody. I am now going to, let's open this up to questions, comments, thoughts, and ideas. And we're going to start with anybody who's got questions specifically about this geology business that we are messing around with, or if you've got some geology moments in your own journals that you wanted to share, that would be really fun to see. So let's start with Livy. Hold on, we're going to allow you to unmute yourself in just a moment. I am, all right, you can now unmute yourself. And I am going to bring, there's a question from Livy. If you want to turn on your screen, you can. And if not, you can also just unmute yourself and ask your question.
Hi, John. This was a really great workshop. I haven't been to on a, this is my first workshop attending, so thank you very much. I realised my spotlight is currently drowning me out. I'm actually a geologist, so it was really good. Like, most of the time we don't even remember the names. Like, everything that you were saying was like 100% spot on. If you write detailed enough descriptions, you go back and look at the references, no one remembers all the names.
Well, that makes me feel a lot better, because I'm always like, you know, is this a yeah, right. So I'm not the only one. That's great to hear.
Oh no, 100%. There's too many names, they make them all up. But the one thing that I would like to say to everyone, like, all the principles with the 3D shapes and like doing the outward the magnification model, we use them in our geological notebook. So it was really nice to see what you use for your nature journaling in comparison to the scientific things, because I'm hoping to teach a few more people about geology. So it was really inspiring. Thank you.
That's really exciting. Do you have any of your own geology notebooks accessible to you right now?
You can go and grab one if you want.
I would love that. I would absolutely love that. Okay, folks, this is cool. So there's a working geologist is about to show us their notes, their field notes. This is a big deal. This is really, really cool. And you know, the tools that they're bringing to the table are, you know, they're trained at observing and asking questions and, you know, noticing things. Like something like if nobody's saying like, you might want to check out the grains in this. Once somebody points that out, then you can like, oh, of course I would. But a geologist has got much richer years of practice and study of the sorts of details that they're going to look for. So, oh, this is going to be cool. You just made my day.
This is basically my degree. I work in a museum as a geologist, so I'm not fully trained in the field. Well, I am fully trained, but I'm not in the field most of the time. I'm mostly organizing rocks and whatnot. But I have to say my drawings are definitely not as good as yours, John.
No. Right, and so in the Nature Journal Club here, we're really clear. We're about ideas, not art, right?
And that's the whole premise of what we have to do with our geology. So I don't know how well you can see this. It's all in pencil, because otherwise it'll end up washing off in the rain. This was a drawing that I did to try and
well, yeah, let's see if
I've got terrible lighting. I'm sorry. This might be better. No, it's worse.
Oh, that's worse. Yeah, shine. If you shine the light at the ceiling.
Oh, there we go. Okay.
Oh, that's much better.
This was a diagram that I used to try and explain the geological formations of Cumbria.
Mm-hmm.
that's where I'm based in the UK.
Yeah.
But we have lots of different, you're mentioning about logs. We call them logs, stratigraphic columns, but we're too lazy to give them their full names. Yeah, we have diagrams and stuff of like.
Just hold it still for a second, and the camera will focus.
There we go.
Yeah.
You can hardly see it. I'm so sorry. It's because of the pencil.
No, that's all right. So
but that's like meandering rivers and being able to see the paleoclimate.
Yep. And so,
all the stuff that you're talking about is what is similar to what we've been doing, but yours is far prettier. I wish I'd learned from you first and then did my notes.
Well, that's really cool. And do you have? Is there some in one of these journals? Do you have a study of a road cut? Is there a study of a road?
There will be one. There will be one, definitely.
So
times that we stopped by.
A good road cut. So places where a sort of road crews have cut through a hillside in order to build a road through. For geologists, this is it's like it's better than your birthday, because it allows you to walk through the middle of a mountain. You get to walk through the middle of a mountain and look to the side and look to the side. And instead of just guessing what is going on there because of what you're seeing on the outside edges of it, you get to, you've come up with your thoughts about, like, I think this is going on and I think that this is going on here. And then you get to the road cut and it's like, oh, this is actually what is going on here. So you get to see if all of the inferences that you've been making are kind of pan out there. So they're great things for giving us sort of a deeper view. Oh,
I
boy.
think this one is a road cut.
Okay. Oh, yeah. So talk us through kind of what you're seeing here with these different layers.
So we have your conglomerates here, and then there's a massive gap, and you can see that there's some beds going along this way, but in fact, and there are some going this way as well. Yep. So that means that there was, as you were saying, the rock has folded itself in some way and then been cleaved off, which is known as a unconformity. Mm-hmm. We've had more deposits on and more shifting of the rock. It gets really quite messy, but
not just messy. It's brilliant and beautiful, right? So yes. you're seeing these. You are seeing these. You're seeing the. Hold on, I'm gonna change my view back to this. Sort of, let's say you've got a column that you're finding where you have, in this section here, you have layers that are oriented this way, and then there's an edge to that, and all of a sudden up here, you're looking at layers that are kind of coming in like that, right? And then there is some other kind of weird thing, kind of what's happened here, and then on top of that you've got layers that are put down flat. Well, what we figured out is that these layers, they form horizontally, right? And so layers can form horizontally, and then the next layer wants to form on top of that, so that the oldest ones down here, the youngest ones up here. But if a big erosional event comes along, like a great big eraser, you can lose, a whole bunch of that information. And if this whole block gets turned on its side, so that horizontal is now laying things down this way, you can get all sorts of crazy stuff. And so what you're trying to do by looking at these layers and where you've got these unconformities between them, you are rebuilding the history of, like, each one of these is a little history lesson, and you're rebuilding that whole history story. So let's look at that again, because that is so cool what that your road cut drawing there?
I just see it a bit like time travel. You know, you actually get to look at the rock and see something that was created millions of years ago in a completely different environment to the one that we're in now. And it's so great to just look at something and be like, I know what that was. Like with the stratigraphic columns, this is, oh God, this lighting is so terrible. I apologize. I don't know what to do.
We'll just kind of doing our best. Oh, yes, yes, yes. Look at this. Look at this.
I can get it at the right angle. There we go. Okay,
Yep.
I got it. You can see that there's the thinner bits and then the thicker bits. But in geology, we tend to associate that with grain size, which happens to sometimes coincide with erosion. But that's why we do the columns as they are like this. And we have like different symbols associated with different types of rock. So you have the rock type up this side, and then you have the different grain size this side.
Oh, that's so brilliant. That's brilliant. So she, Livy has a, you know, so let me just bring this on from my favorite little book here. Livy was just talking about how you've got these different symbols for those stratigraphic columns. You know, you can, there are for here's dolomite and here's a dolomitic limestone, right? And so with the little sketches that they're making, the geologist can record details of you know, of these different sorts of rock types. And so just like with reading a map, you've got a symbol that means school. You're reading a map, you've got a symbol that means capital. With this, what you do is you memorize these little patterns that say, like, for a silty sandstone, for a siltstone, for a mudstone, for a shale, for a pebbly mudstone. You won't have to memorize them all, but you would memorize the ones that are going to be useful for you in the area where you are going to be collecting your notes. Oh, Livy, that is so much fun. Are there any other real geologist notes that you can show us?
I was trying to find my thin section book. So what happens, we get rocks and we take a really ultra thin slice of them and then we look at them under a microscope, and it's absolutely gorgeous. It looks like a kaleidoscope, and we had to sketch them out. And I was trying to look for it, but I can't find it at the moment. It's not to hand. But those are particularly good. I was trying to have a look through. It's just the lighting in here. I wasn't expecting to.
Well,
in my other room, sorry.
Yeah, no. Then we made you run over, get all your journals off the shelf. Livy, thank you so much for on the spur, the moment, grabbing your geology notebooks and sharing those logs with us. That is.
Luckily, I've been using them for my job, so I knew where all these were.
That's right.
Otherwise,
now,
yeah, thank you.
If you tried to just keep all that information in your head without putting it down on paper, what would the outcome be?
It's not possible. You can't keep a record. You can't refer back. You're not going to remember all the grain sizes. You're not going to remember all the different rock types. It just does not work. And from location to location, if you don't put like locality 2 or where the GPS is, you will not remember by the time you get back. It's just not possible. And you end up dreaming about rocks if you do too much field work as well.
Oh, that is so much fun. Hey, would you be interested in sometime coming back and doing a deeper dive with us on this? I'm just sort of seeing in the chat that people are so excited to meet you.
Oh, bless you guys, thank you. Yeah, I'm sure I could put something together, and it'd be nice to actually get some more practice with teaching and whatnot. So yeah, I'd enjoy that.
Oh, that would be spectacular. Could you send me an email, just johnmuirlaws@johnmuirlaws.com, and we will start to sort of chat, and it would be I'd love to kind of dig deeper into geology with you.
Oh, I'd love that. Any opportunity to teach people how to time travel, I'm definitely up for it.
How to, yes, exactly. All right. So would folks be into time traveling with Livy? Oh, I think
Loving
there's
this.
a very enthusiastic response. That is so much fun. That is so much fun. That's
Oh,
cool.
wonderful. Well, I've got to head off because I've
All right.
just
Hey,
missed
thank
a
you
phone
so much
call,
for
but I
being
will send you
here.
an email. It was wonderful meeting you guys. Take
Hey,
care.
great to meet you too.
Bye.
Bye bye, Livy. Oh, wow. Whoa. Wasn't that crazy? That was so cool. All right. So we got to hang with Livy the geologist a little bit there. Um, and what an opportunity. What an opportunity. So is there anybody else that has geology related things or questions specific about today's, and then we might be able to go into some more sort of general sharing about other things in our journals. Is there anybody here who lives in a place like Utah or something where you have just geology writ large across the landscape? You've got that going on, Sarah? Oh, so I've got some envy
Yeah.
there.
Up in Sonoma County, we have so many different kinds of rock formations and geologic areas named. We refer to our local state park, Trione Annadel State Park, as Rockadell because it's got so many different kinds of rocks. Everywhere you step, there's rocks. And there's so many different kinds, and some of them have been dated to 10 million years old. So there's just so much. And then like out in the West County, we have the Cedars, which is all a huge serpentine moonscape with a totally different ecosystem. So Sonoma County, just right here, we don't even have to really leave the Bay Area. We can find so much going on.
I'm really looking forward to when we can get where we can get our live events going. It'd be fun to have an event in the Cedars. It would be fun to go to your Rockadell Park.
Yeah.
It would be, oh, what a delight. Yeah, so wherever you are, there's different geologic history, and what I really want to encourage people to do is to start digging into the story told in the rocks where you live. And I think that what you will find is that it gives you a different sense of place. A different sense of place. So again, there's rocks on the ground, then there's rocks embedded in place, and those ones are tied to the story, right? So just like we say with a nature journal, a page on the nature journal page, I want to put the metadata, the location, and the date. When it's georeferenced and date stamped, it becomes data. That page floating on away from all that information is just there's some notes about a flower, but it's not as rich data. In the same way, a rock that is embedded in the formation that it came from is connected to its roots. It is connected to its metadata, its history, and you're able then to kind of get into the story of those rocks and time travel. So let's now also open this up to any other sort of journaling discoveries, observations, moments, journal pages that people wanted to share, questions, comments, thoughts, and ideas. All you have to do is use the raise hand button that's over in reactions, or hold your journal up to your page. And I'm going to bring on Walters. And hey, it's great to see you.
Hi. Yeah, so I wasn't able to attend the whole class, so I didn't really catch what was going on, but I had this rock that I wanted to share last time, but I said I forgot my journal at my mom's work, and nothing. It was just nothing other to journal really there, so I thought I'd give it a go, and I didn't know how to start, but then I remembered from your book you had these examples that how you drew rocks, and kind of to show how they are turning and what places are in shade. You use these kind of stripes going in one direction, and I tried it and it looks pretty good. So you can understand that here is kind of a side and it's going downwards, and here's a bit lighter. Here was some moss, that's why there aren't any stripes. There's some moss growing on the rock. And also interesting detail, there was an owl's like
pellet?
What they call it, they eat a mouse and then
the owl pellet.
Yeah. There was an owl pellet on top of the rock. So
from what type of owls are in that area? Did you think about
well,
that?
I don't know. That's one of the questions I asked, because this is on an island in Estonia. So that's a question I asked, but I guess there's I don't know, barn owl least likely, like long-eared owl probably, Earl owl.
Wow, that's cool.
Something, yeah. I don't know, but I'm gonna check on that.
I like also the way that you did that little inset box where you didn't have to put color across the whole thing, but you wanted to sort of show those colors in that little strip. And that gives you, just a lot of information. I think that's a great tool, both in landscape drawings and something like this with the rock itself. I also do get the sense of the planes where the angles on that rock change. That's really cool.
Yeah, I did it a bit too small. I should have done it bigger, because it just now it looks like a bit like there's just colors squashed together. If I would done it a bit bigger, it would have some kind of a bigger formation, and it would be good. But this is also fine. Yeah. And one thing also here was from yesterday. So these little fun birds, these are long-tailed tits, they're called. And they're really these small birds, like this so big, but the tails are like twice. They're even longer than I drew here.
Yeah.
And they just look like little flying snowballs in the air.
Yes. And I also really like the way you are just suggesting the wing details and things on this. It's not overworked. This is sort of what you would really see from a distance of, sort of standing there with your binoculars. What a cool little animal. That's really fun. And so it's also got white outer tail feathers on that ridiculously long tail.
Yeah, but it's even longer. It goes up to here, at least. I was just I drew it smaller because, well, my brain thinks it's really long, and I didn't want to like overdraw it. So but it's fun to see these guys. We don't have them nesting, they're only migrating through here. So it's only you can see them in spring and autumn, and it's good to see them again. So was excited was excited about that. This is from today. Really like how this one turned out. I tried to show kind of the autumn colors behind the heron and how white it is. Really like how this turned out.
Yes.
And this is taken, saw it somewhere, I think also from you, that kind of suggesting the shadow, a bit of like blue here in these areas, really kind of helps to show how the bird is not only like 2D flat, but also in depth. So this one turned out pretty good.
That little crisp shadow, that's really effective. That's really, really effective. Oh, what fun.
Yeah.
And then drop down a little bit. There we go. Oh, this is the bird from all of these different angles, from the back, from the 3/4 view there, from the side. I like the arrows showing the movement too. And then zooming in on that head, that little bit of green by the eye. Isn't that an interesting observation?
Yeah, beautiful birds. There were 5 of them in this pond, so
Wow.
quite a big number of like individuals. Usually they travel alone, and so. And one last thing, whilst my journal was away, this one, I took out my old journal and I have some pages kind of left here. Like this is the last page, and I left some blank pages here because in the end, because I thought that I might need to use it, and I did. So so just, it was good for a day to be back on toned paper. It was really, really good. It felt good. So this is a wren that we have, and it was this behavior that I haven't seen before. It was jumping on the ground, and I've seen kind of them landing on the ground, but this was like a thrush, like, or a blackbird, or a common blackbird does this. So this was a behavior that I didn't see, and it was catching flies on the close to the ground. So I wrote maybe a fly catcher, like kind of maybe this isn't a wren all along, maybe it's a fly catcher, really. So in some of the plants in the dunes in the nearby nature reserve. And this was the last. This was kind of an inspiration from the video that you did on sense of place. Yeah, it was sense of place. And I just did a little kind of, I was sitting on a log here. This is like an old riverbed, and just documenting what was growing on the single kind of fallen tree. So there were these interesting plants kind of with these
what a strange
circles.
leaf formation.
Really.
Wow.
And what was interesting to me, usually I think it's usually the other way around. Like at the bottom are the biggest ones, and then it kind of grows smaller. But this one was exactly the opposite. So smaller ones and grew to a bigger one, but at the very top, not 2, but 1 kind of leaf. So interesting.
That is really cool. That's really, really fun. And I like these little, just the little simple side view diagrams do so much to just kind of record details of location and our sort of our place in it. That's great.
Yeah, that's all.
Falters, thanks so much for sharing that.
Yeah,
really,
thank
really
you.
Cool. Great to see you.
Great to see you too.
And the new time working for you?
Perfect. I wasn't able to attend because I had training, but other than that, the time is perfect.
Excellent.
Thank you very much.
Well, thank you for being here. Let's bring in Ray Bonto and see what's happening in your journal.
Hi. So, This is the only bit of geology. And then I got distracted by celodangs and stuff.
Got distracted by what?
Celodang, it's a Indian cowish buffalo in between sort of thing.
Oh, look at this. Now I love the way you're bringing all these different colors into this. What a solid drawing. Really hitting those dark values, the blues and the warm pinks in it. That's really, really exciting.
They have as you can see, they have a lot of muscle.
Yep.
And they're huge, like 6 or 7 feet to the shoulder.
Oh.
It's like 11 or 14 or something of that sort, long feet, and they weigh 3,300 pounds.
Wow, that's a lot of critter.
Yes.
But hold that up again. So everybody look at the dark areas in this and notice how you're not just taking like, I'm gonna get my black paint and go blah, 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 blah. There are blues in here, there are browns in there are pinks in there. There's all this sort of variety of colors that sort of builds up all of those darks. And then the full value range goes all the way to really dark. I think those are some of the things that make that, just such a striking and effective picture. Oh, that's really fun. Yep, you're getting the anatomy of the elephant also really well, just like we saw in your drawing the last time. You understand how the legs bend. This really has a solidity to it.
And I decided to use that style again.
Oh, that's really fun. No, I really I feel the form on that. Oh, thank you.
Thank you.
Oh, great. Really fun to check in on your journals. Let's see what's happening in Joni's journal.
So recently, I went kayaking for the first time and had great fun. And it was with a tour here locally. And we went out on the Monroe Reservoir Lake and then back into North Fork, which is a nature preserve. And it's channels where you can't get there unless you were kayaking. But the thing that really stood out, and I still am amazed at, was it was a full spread, but this is what I wanted to point out. There was a tree that looked like a snag that was left, but this is it full. I'm guessing it was like 5 to 6 feet tall from the bottom to the top, and it had beaver chews. The beaver had worked it, but this is above the ground. And so, this is all air and it was just amazing.
Joni, we've lost your.
And of course, I had questions, and was the water level which? Okay, can you hear me right now?
Yeah.
Okay. This, I don't know if you'll be able to see this. This is the photograph I took with my phone from the water from being in the kayak. Kind of hard to see.
Yeah.
But it was just truly amazing to think that the water level had been that high at one time to allow the beaver. And I even speculated perhaps there was a lot of debris that created a platform, perhaps, enough reeds, cattails, limbs that maybe were carried by the water and allowed it to perch on that and then do its chewing. But it's just an amazing monument to the beaver.
Yeah, and it's fun to kind of look around in nature around us and find those little moments that where we kind of go like, and that doesn't make any sense to me, right? You know, how did this form? So not just, you know, looking for the things that we know, but looking for the things that we don't know, and using the journal to kind of record information around those mysteries.
Right.
Up in the Sierra Nevada, I find a lot of places where there are high beaver chew marks because the beaver was standing on a snowpack.
Oh.
But it sounds like your area is not really a snowpacky thing. So then you have to find other ways that the beaver could have gotten up that high. The levitating beavers hypothesis has a number of flaws with it, but no evidence yet of those levitating beavers, or the cooperation between the beaver, you know, where the osprey just holds the beaver up so it can chew higher. That's so much. That's really fun.
Yeah, that was one of the best things I've seen in all my years. That was pretty cool.
Yeah, great mystery. Great mystery. Thank you, Joni.
You're welcome. Thank you.
Bouncing back over to my gallery view. Would anybody else like to share something that has been happening in your journal? All right, Sarah. Hey there.
Hi. So I went for a walk on Tuesday morning all around the Laguna de Santa Rosa. It's one of our local, it's a big marshland that drains into the Russian River. And it was mainly just kind of a walk to get together with a friend who I haven't seen for a long time. And I took my journal with me and started noting all the bird species, because that was one of the big things that we were looking at, and then spent a few minutes at the end just sketching a few things. So it kind of came out as a messy page, but I'm really happy with it because it really recorded our experience. So let me see if I can get this up here. Let's see. So it's a list of bird species, because we saw 28 different species. Let me back that up just a little bit. There we go. So the words, of course, are backwards. A sketch of the California poppy, because there were a couple of little plants and the color was just intense orange. So I'm looking forward to coloring that with some colored pencils. And then just practicing getting poses of a great blue heron, and it was preening at one point.
Oh, nice.
And then just kind of sketching one of the big valley oak trees just to kind of have the shape of it. The bird species was really fun. So, and hearing the song sparrows, or the songs of the different sparrows, it was just really fun. That just kind of turned into a totally unorganized, kind of, for me, messy page, but I really enjoy it as kind of a diary of the day.
And those lists are also, whoops, I just made you disappear. Hold on a second.
That's okay. I'm still here.
So yeah, lists like that are really, really useful. Scientifically really useful. Like, this is here who's, and because you've got the location and the date, that list turns into data.
Yes. And one of the fun little things that we had happen to us, which I didn't write down, but I want to remember and write it down, maybe even journal it, was at one point we were talking about where are the bald eagles on the Laguna, and we know that there's 2 nesting sites. So I was asking my friend, so do you know where those are, you know, roundabout, kind of just generally. And so we were talking about that, and then suddenly we were, oh, look, what is that? And there was this big black bird flying kind of towards us, and we thought it was a bald eagle. Both of us did. And we were like, oh, get our binoculars out. It was a huge raven with a big piece of white bread that it had just picked up from the local high school during lunch break.
That is really funny.
Talk about a fake out. And, you know, we were just so excited, and then we realized really what it was. And we're like, oh, well, okay, that was cool anyway, because it was a really big raven, but that was one of those fun nature fake out moments.
That is really cool. That's really cool. Yeah, I once had, what was it? a very sort of similar experience where I was leading a group, and I spotted the bald eagle and pointed the bald eagle out to everybody, and it ended up being something very sort of similar to that. I forget the details of that, but yeah, it was another bird carrying something else that was white, and but yeah, I love the big piece of bread and the raven. That's cool. Especially when you've primed yourself, like, I wonder where the bald eagle nests are. Bald eagle, bald eagle, bald eagle, bald eagle, bald eagle. Now you see a large, dark bird with a white head flying towards you, and you're like, yep, that's cool.
Thanks, Jack. This has been a great class again.
That was fun. And also fun to meet our new geologist friend. All right, so in just a moment, I'm going to be turning off the recording. Before I do, I just want to encourage everybody again to try to sort of find out about the bones of the land near you. And either at the level of the rock or the sort of rocks in place and the structure of the landscape. See if you can start to explore that in your nature journal. Again, it's this window into our past, and absolutely fascinating. So thank you all for being here, and I hope you had fun in this workshop.